So in the world of astronomy, people who do this kind of stuff and study this sort of science, apparently the find of a black hole in the Milky Way galaxy was the Holy Grail. I saw people reacting to this, very exciting, a lot of people applauding this find, and apparently...
Well, that's our galaxy, right? So we're in the Milky Way galaxy, I think. We'll find out. I think that's our galaxy.
Happy to call it ours if it is. Avery Broderick is with the Delaney Family John Archibald Wheeler Chair at the Perimeter Institute. He's also an associate professor at the University of Waterloo and very much involved in this latest discovery. Mr. Broderick, let's start by talking about just how significant this is.
Hi, Aaron and Natasha. Very happy to be with you. Yeah, so Natasha, you're right. The Milky Way galaxy is our galaxy. So this is our black hole in some sense, right?
Cool.
The supermassive black hole next door, as it were. And we knew there was a dark mass at the heart of our galaxy, and stars orbit that dark mass. And a couple of years ago, Andrea Ghez and Reinhard Genzel won the Nobel Prize for following those stars for 20 years and demonstrating there had to be something there. But just yesterday, I think we confirmed that dark mass is, in fact, a black hole. It does have that event horizon, that point of no return, after which people stop responding to your tweets.
Okay, pardon my ignorance here, but when I asked you off the top how significant this is, we've always had a feeling this sort of black hole existed. What's the significance necessarily of finding this within our own galaxy, and what does it tell us about, the world?
So 3 years ago, we talked about a black hole that was 54 million light years away, right? So when the light left that black hole to come to us, the dinosaurs had just gone extinct. The one in our galaxy, much closer, also much smaller. At 27,000 light years away, we can see a black hole that's 1,500 times less massive, 1,500 times smaller. And in some sense, where the black hole from 3 years ago was really a heavyweight, very unusual and extraordinary object, the one in our galaxy is, more typical, more common, dare I say pedestrian, if you could ever call a supermassive black hole pedestrian. And, something that's exciting to us is even though these two objects are different in nearly every way imaginable, here we have the black hole in the center of our galaxy, this much more common type of object on a starvation diet, as it were, looks strikingly similar to that more massive, maybe more atypical object from 3 years ago. And that's because what drives that image, that dark shadow, that silhouette of that event horizon wreathed in the bright luminous plasma, that's really gravity. And that's what we're here to study.
I'm realizing that, we're talking about a black hole, and even I'm like, oh, cool, the black hole's been found, and we're finding out all about it, but I don't really actually comprehend what a black hole is. Is it, when you say gravity, and I imagine it as like a void or nothingness, what is a black hole?
Yeah, so it's gravity run amok. If you one of the realizations from Einstein's theory of general relativity, and in fact it was a very early realization, was that if you take that theory seriously, if you concentrate enough matter, there is nothing that will hold it up. It will collapse ever more into a singularity, a point of infinite density, and that is hidden behind. It develops that event horizon, that point of no return that is characteristic of a black hole. And while not everybody is motivated, I suppose, to work through the math, I think most people kind of get the concept, right? The idea of that perfect prison, right? That point of no return, and that's essentially exactly the right idea.
Does that kind of mean, pardon my ignorance again, that if you were to be able to travel to this particular black hole and go all the way inside, you could actually travel in time, like back in time?
Well, so currently, the equations of general relativity do not permit you to time travel after having traveled into the black hole. Of course, one of the great mysteries is because you can't come back. We don't really know what happens inside. And this is one of the motivations, one of the key outstanding questions in modern physics is how do we connect up this theory of the very large, Einstein's theory of gravity, with quantum mechanics, this other extraordinary success story from the 20th century, the theory of the very small and the very cold. And we know they don't match. And maybe your time travel is somehow going to be found when we figure out what the right way to connect these two pillars of modern physics together. And if we find how to connect them, my bet is on we're going to find it around black holes.
And does that mean one day we would send, a probe to try to get some of these answers, or is that not possible?
Feasible, yeah.
Well, it depends on how long you want to wait. 27,000 light years is a long trip.
Oh.
But this is one of the wonderful things about astronomy, is that by peering out into the universe, we're able to access laboratories that are simply impossible to recreate here on Earth. And while we can't interact with them, by carefully studying them, by looking at them over time and carefully modeling them, we can use them to answer these kinds of questions. And that's exactly what the Event Horizon Telescope's all about. We can't travel to the black hole at the center of the Milky Way. It's, I've been told by the personnel of the people at the university that I'm not allowed to send undergraduates across black hole horizon at the Event Horizon.
Good to know.
There's a lot of paperwork, but nevertheless, we can study them with computers and with telescopes, and that's in some sense the next best thing. And that's one of the reasons why I'm an astrophysicist. I want to make use of these amazing natural experiments.
Yeah, it's a pretty amazing story. We have to go to news. I have one quick question. You said this is 27,000 light years away. How many light years away is Mars? How far is Mars relative to this?
Oh, Mars is something like 20 light minutes or 40 light minutes, right? So
it's a shorter trip.
Way closer.
Just checking.
Yes.
Thank you so much for your time. Appreciate it, Mr. Broderick. Thanks a lot.
My pleasure.
There you go. By the way, didn't I hear if you wanted to go to Mars when we finally send people there, that's still like a 7-year trip, and that's only like a fraction of what it takes to get to a light year? Wow.
My brain can't process this.
There's a lot.
As cool, as astonishing as it is, it still kind of freaks me out.